Hello friends. So today in this lecture we are going to discuss coefficient of variation, that is CV. Coefficient of variation, that is CV, in short CV. In previous lecture we discussed about measure of central tendency, measure of dispersion, and in that we learn about deviation, about mean, deviation about median, then we learn about variance, right, that is standard deviation, then variance, and now the another measure is coefficient of variation. So formula for coefficient of variation CV is S upon x bar, where S is standard deviation. Either you can put here sigma also, right, either S or you can put sigma. So sigma upon x bar, that is, this is standard deviation, x bar is mean, and we have to multiply by 100. That is always your CV is, answer of CV is in percentage, right? So from this CV we can compare a given data which is more consistent or more reliable data. For that, what we have to measure it for that is if a smaller value of CV, means if there is a CV is smaller, then that group is more stable, that is consistent group, and the larger value of CV means that group is more, shows more variation, means CV of the group is smaller, then that group is more consistent, right? And if the CV of the group is larger numbers, right, then the group has more variation, right? So for comparison of two groups you need to compare a CV, right? And the formula for CV, that is coefficient of variation, is standard deviation upon mean, right? This is standard deviation, this is mean, into multiply by 100, right? Now we have to compare a comparison of two frequency distribution with same mean. If two frequency distribution has same mean, then see, first distribution, this is second distribution. Now for first distribution mean is x1 bar, and for second distribution mean is x2 bar, and standard deviation we require, that is standard deviation is either sigma 1 or s1, you can take any one symbol, and this is sigma 2. But what is our question? With same mean, means mean is same. So if mean is same, then x1 bar is equal to x2 bar, and we are taking considering this value as x1 x2 is equal to x bar, that is mean, right? So your CV will be as from formula standard deviation upon mean, that is standard deviation S1 of first group, right, upon mean we are taking x bar. So S1 upon x bar into 100 and S2 upon x bar into 100, means in denominator x bar are same, there is same mean, then everything depends upon S1 and S2. If S1 is the smaller, then CV of this is smaller than S2. So it is clear that CV can be compared on the basis of values of standard deviation, right? So because this mean is same, so CV can be compared on the basis of standard values of this standard deviation. So everything depends upon standard deviation while there is a same mean. Thus we can say that for two series with equal mean, if series is given has a equal mean, then the series with greater standard deviation has a more variation, right, or more dispersion than the another group, right? So also the series with lesser values of standard deviation, means if standard deviation is less, then that series has not more variation, right? So standard deviation is high, then variation is high. Standard deviation is low, then variation is low. So everything is depend on standard deviation while a given mean has a given data has a same mean, right? So remember one thing. In short, if x bar is same for two series or comparison of any data, if mean is same, then everything depend on S1 and S2. That is, everything depend on standard deviation. Standard deviation is high, then that group or series has a more variation, and standard deviation is low, right? So suppose this is S1 and S2. If S1 is less than S2, S1 is less than S2, means group first distribution, either group 1 has lowest variation and group 2 either second distribution has more variation, right? So CD always depends on standard deviation while mean is same. That you have to remember, and remember this formula: CD is equal to standard deviation upon mean into 100, right? So now question number 3. Given that two plants A and B of a factory show following results about the number of workers and the wages paid to them. So plant A, plant B. Number of workers given 5,000 and 600, right? This will be 6,000. So worker are 5,000 and 6,000. Number of workers, that is N. This is N. Average monthly wages. Average monthly wages, that is your mean X bar. So this is your X bar is given for plant A is rupees 2,500, and for plant B it's also rupees 2,500. Means the mean of both plant are same, and then variance of the distribution of wages. This is variance, right, of the distribution of wages, that is either S square, either sigma square, is 81 and 100 respectively given. Then question is, in which plant A or B is there a greater variability in individual wages? We show here average monthly wages, that is mean. Average monthly wages, that is mean, that is X bar, that is X bar of both plants A and B are same, that is 2,500 rupees. So the plant in which there is a greater value of variance, right, is more variable, right? So here is 81 in plant A, and in plant B it's 100, right? So greater value of the variance is 100. So plant B has greater variability in individual wages, right? So plant B has, our answer is plant B has greater value of variance or standard deviation. So plant B has greater variability in individual wages, right? Because here variance is more than plant 1. So plant B has greater variability in individual wages, right? Then another question is question number 4. An analysis of monthly wages paid to workers in two firms A and B belonging to the same industry gives the following results. So here again given comparison of two firms A and firm B. First, number of wages earner, that is number of wages earner, that is number of workers, that is this is given is N, number of workers is N given. Mean of the monthly wages, that is mean, that is X bar is given, average value is given, and variance of the distribution of wages, variance, that is either S square, either sigma square is given, either this is given, right? So which firm A or B pay larger amounts as monthly wages. So we have to compare which firm, A or B, pay larger amount of monthly wages, and second one is which firm, A or B, shows greater variability in individual wages. So there is two questions. Now again see here, for firm A, mean of the monthly wages, that is X bar, is rupees 5253, and for firm B also rupees 5253, that is 5253, means mean is same. Now mean is same here again. So if mean is same, then everything depend on the standard deviation or variance, right? With variance greater has a more variability. So here variance of firm B is greater than the variance of A, right? So firm B has a more variability. So which firm, A or B, shows greater variability, that is firm B with greater variance has a more variability in individual wages. So second answer is firm B, right? So I am writing here firm B, and reason you know, because of, I am not writing, listen, because of same mean, right? A firm which has a more greater value of variance, has more variability, right, in individual wages. So firm B has more variability in individual wages. Now for first question, which firm, A or B, pay larger amount as monthly wages, right? Which firm, A or B, pay larger amount as monthly wages, means monthly wages. Now formula for mean, X bar is equal to sigma xi upon n, means you have to count sigma xi, that is n into X bar. So for this variability of monthly wages is multiplication of this. So for this, if you multiply 5253 into 586, then your answer will be 3078. Answer will be 258, right? Is 258. And if you multiply these two, 648 into 5253, then answer will be 340. Answer will be 3403944, right? So 3944. So this is your monthly wages, right? So here you can see that this is 3078255 and this is 3403944. So firm B has paid, that is firm B pays a larger monthly amount of wages, that is 3403944. Okay, got it? Thank you. So next question is illustration number 15. Given that the following values are calculated in respect to height and weight of the students of a section of class 11, can we say that the weight shows greater variation than the heights? That means we have to calculate the CV. If CV of the weight is more than the CV of height, then we can say that yes, weight shows greater variation than the heights, right? And the formula for CV is, you know, SD upon mean into 100, right? So for CV, this is the formula. CV is equal to standard deviation upon X bar into 100, right? This is the formula for CV. That means we require standard deviation and mean. So here mean is given, that is this is your X bar. So X bar is given here. Variance, that is sigma square, either S square, I am writing S square. So this is S square is given. So now we require standard deviation, and you know standard deviation is equal to positive square root of variance. Standard deviation is positive square root of variance. This is a known formula for you. Standard deviation is equal to positive square root of variance. So first of all, we find out standard deviation, that is square root of, I am writing only S square here, right? I am writing only S square. So square root of 127.39, right? You know, square of 11 is 121. So this is 11 point something. So this will be, if you count, this will be 11.3 centimeter. 11.3 centimeter for height, and standard deviation for weight. Now this is 23, right? This is 23.161. Now square of 4 is 16 and square of 5 is 25. So square root of 23.1361 lies between 4 and 5. That is, this is 4 point. Now this is 1364. That is approximately 81 kilogram. That is kg. That is, this is your standard deviation for height and standard deviation for weight. Now for CV, formula is CV is equal to standard deviation upon x bar into 100. CV, formula for CV is equal to this, right? That is, CV for height is equal to, CV for height is equal to standard deviation is 11.3. So this is 11.3 whole upon x bar, mean is 162.6. So this is 162.6, right, into 100, into 100. So simplifying this, we will get 6.95. We will get 6.95. I know this answer, that's why I am writing. You have to calculate using calculator or orally, whatever you know and what is whatever suitable for you. Now for weight, C is 4.81 whole upon x bar is 52.36. So this is 52.36 into 100. So simplification of this is 9.18, is 9.18. So CV of weight is more than the CV of height, right? So clearly you have to write, clearly CV of the weight is greater than the CV of height, right? So clearly CV of weight is greater than CV of height, CV of heights, right? That means, therefore we can say that the weights shows greater variation than the heights, either more variation than the height. So therefore we can say that weight shows either more, either greater variation, right? Shows more variation than heights. So more variation than height. Okay, so this is your answer. So you know, if CV is less than, then the data or that series or height or weight, for height or weight, if CV is less than, then that group is more consistent, right? And if CV is greater than, then that group or series is more variation, right? Question number 14. Coefficient of variation of two distributions are 60 and 70. So two distributions are given. Suppose this is first distribution. So first distribution and second distribution. Right? For first distribution, CV is 60 and 70. So CV is given, CV is 60 and for this 70. And there is standard deviation, that is SD. So SD are 21 and 16 respectively, 21 and 16. So this is given. So I am preparing table, so it is convenient for you to calculate, right? So no need to calculate differently. Now formula for CV. CV is equal to, formula is standard deviation upon mean, that is x bar, into 100. This is the formula. Standard deviation upon mean into 100. Are you able to read this? Due to this line, this obstacles for you or not? Okay, I am writing. So this is mean, right? So standard deviation upon mean into 100, and we have to calculate what are the arithmetic means. Arithmetic means your mean, simple, right? So substituting for arithmetic mean, so I am writing only AM, arithmetic mean. Either you can write mean only, you can write mean only, right? Now CV for this is 60. So for this calculation is 60 is equal to, standard deviation is 21 upon mean into 100, right? That means mean is equal to, if we make this to mean to subject, then this is 21 into 100 divided by 60. So this 0 cut, right? This is 7 3 ja, right? And this is 2, right? So 7 into 2, and this is 2 into 5. That is mean is equal to 35. Mean is equal to 35 for first distribution. Your first answer is mean equal to 35. So no need to write separately. You can write in this, in tabular form. It's okay, right? Because you are applying this formula. CV is equal to ST upon mean into 100. Now arithmetic mean of second distribution, right? So arithmetic mean of second distribution. Now this is arithmetic mean for second distribution. So CV for second distribution is 70. So this is 70 is equal to, mean is, sorry, standard deviation is 60. Mean we have to find out, upon mean into 100. So mean is equal to, making these two subject, mean is equal to 16 into 100 divided by 70. So this 0 will cut, that is 160 upon 7. So 160 upon 7, that means 22, right? So answer will be 22.85. So second mean is your 22.85. So this is your second answer, right? Got it? So it's very easy examples. Do practice at home. You can solve very easily. Okay.